In this video, we're going to look at solving a system of equations that contains three variables and three equations. And I'm going to take you through the process for this, and I just want you to become familiar with what we're doing. And this is going to lead into our next chapter with chapter 8, where we're going to talk about matrices. But I want to kind of go through the process here of just looking at solving this system of three equations and the steps that we would take to do this. And I'm not necessarily going to make you do this for an example, but I want you to understand how this process works. And we're going to look at some other techniques that will make this much easier when we start studying matrices in the next chapter. So the first thing is we're going to kind of use a elimination process like we did before, and we want to cancel out our variables. And to kind of go through the process here, we want to first start with our first equation, and we want the first term here to have a 1x, which it already does. So for example, if this wasn't a 1x, this first entry here was not a 1x, if this was a number, for example, if it was say 3, then we could divide everything in this first equation by 3, and that would make this a 1x. What we have to remember is whatever we do to one side of the equation, we have to do to the other side. So in this case, we already have this coefficient here of 1 for the first equation here. So we have the 1x, so I'm going to simply bring down this equation as x minus 2y plus 3z equals 9. So now the process is we want to cancel out the x below it. So what do we have to do when we add these two equations together? Well, because this is a 1x and this one's already a negative 1x, we don't have to do anything. We can just simply add the two equations together and they're going to cancel out. So we have x and the negative x would cancel. So that would simply leave us with a 0x. So I can maybe write this in here. That would leave you with a 0x. And I'll just put this as a placeholder. And then we would look at adding a negative 2y and 3y, which would be a positive y. And then notice here, there's no z, so again, this is 0z here, so that would be adding 3z and 0, so 3z plus 0 is still going to be 3z, okay? And then we have 9 and negative 4. Well, 9 and negative 4 would be 5, okay? Now we want to do the same process, but we want to do that with the first equation and we want to cancel the 2x out. So if you notice, we canceled the x out, so that's gone. Now we want to do the same thing to cancel out the 2x. So I'm going to go ahead and erase the 0x, so that's completely gone. What do we need to multiply x by so that we add it to 2x, it's going to go to 0? Well, hopefully you said a negative 2. So if we multiply here by negative 2 and then add it to this third equation, your x will cancel out. Negative 2x and a positive 2x will go to 0. So then we would take the negative 2 and a negative 2y. That's going to give us a positive 4y. So 4y and then minus 5y is going to give us a negative y. And then we're going to take the negative 2 and multiply that by the 3z. So that's going to give us a negative 6z. Negative 6z added to 5z. So negative 6, positive 5 would be a negative 1, or simply a negative z. And don't forget, negative 2 times 9 is a negative 18. Negative 18 and 17 would be equal to a negative 1. Okay, now the idea of what we wanted to do here is we wanted to make all of the x's 0. So here we have a 0x and then here we have another 0x. So we completely canceled out all of the x's below. All right, so the next step is, once again, we're finished with the first equation, so I'm going to copy it down. And there's a lot of copying here, but it's easier to do that than try to do so much in your head and make a mistake. Now, just like we wanted this first equation to have a 1x, once we made all of these below here zeros, then we're going to move to the second equation and we want to make the first entry here have a coefficient of 1y. Well, we already have a 1y, so we're just going to bring that down as y. plus 3z equals 5. Now, once again, just like the first equation, we're done with the second equation. We're not going to simplify that anymore because we already have this coefficient of 1y. Now, we want to figure out what do we need to do to this second equation so that if we add it to the third equation, that these y's are going to cancel out. So just like we canceled out the x's before, we want to cancel out the y's. Well, here we're in luck because we already have a positive 1y and a negative y. So that means they're going to automatically cancel out to 0. So we would end up with a 0y. Okay. And then we would say 3z minus z, and that would leave us with a positive 2z. And then 5 and negative 1 is going to be 4. So once again, if you kind of see the pattern here, we have all zeros here. There's nothing here for the 0x. And then we have a 0y. All right, so once again, we're going to copy all of this back down. We have x minus 2y plus 3z equals 9. The second equation is already set because it has a positive 1y plus 3z equals 5. And now here, with this last equation, we have a 2z. Well, we want this here to have a coefficient of 1. So to get rid of the 2, we need to divide by 2, or we could think of multiplying everything by 1/2. So 1/2 times 2 would be 1z, and 1/2 times 4 would be equal to 2. So now if you look at the form here of how we have our equations set up, the first one we have x is your first 1x is your entry, then we kind of go down, everything below the x is canceled out. As we move to the second equation, we go over 1, we have a coefficient here 1y, everything below the y here has canceled out to 0, and then we move over for the third equation and we have a coefficient of 1 for the z, and that is simply equal to 2. Now, why do we want to go through this whole process? Well, by doing so now, if we notice, the very last equation here, we have solved for z equals 2. So now we know the value of z is equal to 2. And from this point, we can use what is called back substitution, okay? And this is what I would like you to be able to do, at least for right now. Maybe you can go through and study the steps here. And again, this process of going from the original system down to this form, I want you to be familiar with, and again, later on we're going to look at how we can use matrices to make this a little bit easier for us. But I do want you to understand how we can use this back substitution. Well, we know z is equal to 2, so back substitution says we're going to go backwards now and substitute the 2 into the previous equation here. Well, if we do that, we would have y plus 3z. So that's y plus 3 times z, but we know that is equal to 2 equals 5. So the advantage is now that we only have one variable, so we can easily solve for y. So that means y plus 6 equals 5. So therefore y is equal to a negative 1. And then we can go back to the first equation now, where we have x minus 2 times y, but now we know y is a negative 1, plus 3 times z, but z is a positive 2, and that's going to be equal to 9. So that means we would have x, negative 2, negative 1 is a positive 2, 3 times 2 is 6, equals 9. So x plus 8 equals 9. So therefore, x is equal to a positive 1. So what we now have is, instead of an ordered pair, we have what's called an ordered triple, where x is equal to 1, y is equal to negative 1, z is equal to 2. So we would write this as 1 comma negative 1 comma 2. And here we have your x, your y, and your z coordinate. And really what that's looking at here, and I don't want to go too in depth right now, but basically here by having this ordered triple, we have introduced another axis here. So normally we're used to having just our x and our y axis. Well, now we're going to introduce a third one, the z-axis. And the way that we're normally going to draw this is going to be a little bit different. We're going to view this as here your x-axis. We can think of this as coming out of the screen towards you. So this part here coming out of the screen, this is typically thought of as your x-axis, and then the axis going left and right here, this is your y-axis. And then the axis going up is your z. And the x-axis here coming out would be positive. The x going back into the screen would be negative. The y going to the left here is also negative. And then going down on the z would be a negative value. So for example, if we wanted to plot this particular point, what that means is x is 1. So that means the x-axis coming here out of the screen, we would come out 1 unit. Your y value is negative, so that means we would go to the left 1 unit. And then your z is positive 2, so then we would go up 2 units. And then we have a point here out in space. So we're coming out of the screen 1 unit, to the left 1, and then up 2 units. Okay? Don't worry too much. I'm not going to worry about having you to graph this. I know this is a little bit harder to see in a three-dimensional space. So just realize that here you have this order triple. Now we're looking at a three-dimensional situation. But really what I want you to get from this is that if we're having three equations where we have three variables, if you have three variables, you're going to need three equations to solve for the three different unknown variables. And to do so, we're going to go through the process of canceling out your x's below, then you're going to move over, cancel out your y, and then you're going to get your z. And what I really want you to understand is how we can use the back substitution here to go backwards to find the values for x, y, and z. And again, just study this a little bit, and then once we cover into the next chapter, we'll make this a little bit easier when we talk about matrices.